Today we're working on a 2005 Acura MDX. Now the complaint is that the air conditioning was working fine and then all of a sudden it just quit. Now we need to find out why. Now when we're trying to find the problem, obviously the smart thing to do is go with the easiest or the most common problem first and rule that out. Now in air conditioning, when they suddenly stop, the most common cause is it's lost its Freon charge. So that's the first thing we did. We took our gauges, hooked them up, and we hooked to the high and the low side of the air conditioning, and we had 100 pounds static pressure. 100 pounds of static pressure means the system is charged sufficiently so that I don't have to worry about that being my issue. Now another common problem, and an easy one to find and fix, is the AC clutch relay. Now the easy way to fix that is just honk the horn. Now the horn doesn't fix it, but that tells me that the horn relay is good. Now I can come over here in my fuse box, and when I look at my panel, my horn relay is right there and my AC clutch is right there. So I'm just going to switch the two. Now I know my horn relay was working because I heard the horn honk. So with putting it in here, I go inside and turn the air conditioning on. If everything works then, I know as my AC clutch relay was the problem. I did that, the clutch still did not engage, so I know my relay is not the issue. So I'm going to put them back. Now the next thing I wanted to do was command that clutch on myself. So I'm going to use my scanner. Now I'm going to toggle this on. Now if you watch the status, you should see it go off and on. And you should be able to hear that clutch engage. On, off, on, off. Every time I engage that, what I'm also testing is the entire electric system, wiring, controls, and everything, all the way to the AC clutch. Now when I was commanding that compressor clutch on, you could see the screen changing from off to on, off to on. That's the command. So that tells me that the command from my intent to ask for air conditioning was going all the way to the clutch, but the clutch was not responding. Now to gain access to this compressor, it's underneath here. There's a shroud down there, a splash guard we have to take off, and it's very, very tight. So what I'm going to do is take this all off and then put it on the bench and show you how we're going to test this, because that way I can get the camera in there and you can actually see what's going on. Now let's review our electrical diagram first. Now you'll notice here we've got a dotted box, which means there's more to this system than we have right here. But you see down here the AC compressor clutch relay is a solid box. So the entire relay is illustrated in this diagram. If we go down here, we've got another solid box. That means the AC compressor and the clutch. The clutch is a solid box inside the other solid box. So it's telling you that the AC compressor clutch is an internal part of the AC compressor. This right down here is the ground signal. So that means when the compressor is bolted up to the block, that's where the compressor and the compressor clutch get the ground. The power is going to come from a fuse. Fuse 59 is going to go to the relay. When the relay is commanded on, this is the command side. When that electromagnet energizes, it pulls this switch closed and it then sends power. It already has ground because the ground should be there by being bolted up to the block. Now the access to that compressor for testing and video purposes was pretty tough because it's from underneath. So what I've done is taken it out here and set it up so we can see better. I've got the actual compressor that had a problem, and then I've got the new replacement compressor here. This way I can test them both and show you how to do this. Now when this compressor is actually mounted on the car, the engine and everything are up in here. It's bolted on and held on down here. So being bolted to the block, the case for the compressor gets its ground. Now I couldn't get to anything. I had to drop the compressor even to get access to all of this. But when I did, I could see that I've got a one-wire connector, and that is going over here to this plug-in, and that's going to a ground connection. So I'm going to clean this so that you can see it a little bit better. But there is our ground connection. When the case is bolted up to the block, we have a ground connection. This eyelet and the bolt then go into here, into the compressor clutch, and it comes out and we have access here. Now here's our air compressor and the compressor clutch in this solid box, and the ground comes from being bolted on. Let me simulate that. So I have a battery with a positive and negative post. I'm going to take an alligator clip and I'm going to clip onto the negative post. The other end of this wire I'm going to bring over and I'm going to clip it to the case. Now, you know, with the power probe you can tell which side of the battery you're on, because if I touch the positive, I have a red light and it shows the voltage, and if I touch the negative, I've got a green light and the ground. So with this being connected to the case, I should be able to touch this to the case of the compressor and see that we're on ground. So all I'm doing is tapping into the ground from this battery and I'm grounding the case. Now if I continue, since the case is grounded, the case, this screw goes through and is bolted to the case, so this screw should have ground, and it does. Your logic would tell you though that if that goes through there and goes into here, that I should have ground on this wire. So now I'm going to tap into that, and you'll notice I have no voltage. I have no green light. But actually the important thing is there's no voltage at all, so that's an open circuit. Now let me prove that to you in a different way. Now I'm going to use my multimeter and I'm going to do a continuity test, which means I'm going to switch this all the way around. So I'm doing an ohm test and I've got it set for my speaker. So when I touch my two probes together, you should go close to 0 volts at 0 volts and you should hear the sound of the beep. That tells me that I have continuity. Now you know a continuity test does not tell you a circuit is good, it just tells you you do not have an open. If there's continuity, that means whatever's coming to that wire goes through that wire, or there's continuity. It doesn't tell you how good it is because we would have to load test it to find that. But it's telling us when I hear the beep that these two wires are touching. So if I touch this block, which I've supplied ground to, and I touch this bolt, you can see that we have 0 volts, so we're on the ground side, and you can hear the beep. Now, the logic here is that if this bolt is going through this wire, going down through the compressor clutch and coming back out, I should have continuity here. So I'm going to leave this on my bolt there, and I'm going to touch the wire in here. Now if you look at your multimeter, there is no ground and there is no beep, so there is no continuity there. And let me prove that to you on the other one. Now I'm just going to remove the ground from that compressor clutch and I'm going to put it on this compressor clutch. Now the same thing will happen here, but since I've supplied the case with ground, I can go to this bolt and you can see we're on the ground side and there's continuity. You can hear the beep. And now when I touch this connector, I'm going to put it back here. And now when I touch this wire, now you can hear the beep. And you can see that we're very close to ground. There's always some resistance in every circuit. But that tells me there is continuity in there. Now continuity basically means that the ground I'm supplying this case is going through the clutch and it's going out this wire, and I have continuity there. So whatever ground is coming to this clutch is going to go through this clutch. So we've just proved, and we just have our evidence, that the compressor clutch lost its ground. And without a ground, the compressor clutch won't work, and that's why our air conditioning quit suddenly. Now I used this and gave the compressor clutch ground. Now to make it work, I have to give it power. Now since I have the compressor out of the car, I can't use the car, but I can just go to this point and give this wire power, which would be the same as here, and see if the clutch works. So I'm going to go to my connector. Now I'm going to use my power probe, and you know with the power probe, I can send power to the tip or I can send ground to the tip. Well, I'm supplying my case with ground, and I know that I've got ground there. So since this now has ground, I just want to send power to it, and if that's the case, if it works, you should be able to see the clutch engage. Now let's go to the bad compressor. So I'm going to take my battery ground and I'm going to ground this case. And I'm going to go to the wire here because I should have continuity. Now I can confirm that my case has ground that should travel through the clutch and then back out through this wire. So if I give this wire power, well, first off, you can see I have no ground there. But if I give that power, the clutch should engage. Now you can look at the multimeter here and see that I'm giving it battery voltage every time, but the clutch is not engaging. So somewhere between the case, which goes through the clutch, all the way out here, we've got an open circuit. Since we did not have continuity, whatever goes to this wire will not go through it and come out here. So by using a logical thought process, looking at our diagram, we've found evidence that that compressor clutch has lost its ground. That's why we lost our air conditioning, because the clutch would not engage, the compressor would not engage. So we're going to mount this back on the vehicle and test it all again. Now we've got our new compressor in with a new clutch, and now I'm going to command it on and off again. So now when you see the command going off and then on, you can actually see the compressor clutch engaging, and you can hear it as well. Now we've commanded it all on. You can see that the compressor clutch is engaging and you can hear it engaging. So we've found our evidence and we've actually fixed the electrical problem. Now what I really need to do is just charge this with Freon again, evacuate it all out, put the proper charge of Freon in it, and we should be working. So we got the new compressor on, I got it recharged, and it's running. If we look at our temperature sensor, my probe right here goes to the front of the vehicle for my outside ambient temperature, and it says it's 85 degrees outside. Now this wire goes in, and I've got another temperature probe on the inside ductwork, and it says the inside temperature with the doors open is 51 degrees. Now as a rule of thumb, if we get an air conditioning system to drop 30 degrees from outside to inside temperature with the doors open and everything, then it's operating like it should. So again, the key to proper diagnosis is to find the evidence and let the evidence lead you to the problem.